Absolute error and mean absolute error. Whenever we are measuring any quantity, at that time difference between true value and measured value is called error. This absolute error is always positive. After measuring any physical quantity, we are taking number of readings. We won't take only one reading. At that time, we are getting many errors. That total errors mean value is AI. Absolute error of different measurements are expressed in delta A1. Delta A1 is equals to mean value minus A1 error. Delta A2 mean value minus A2. Like that, all delta values, whenever we are taking mean value, means total by number of errors. That is absolute error. Relative error means or percentage error. Relative error means total error. That means mean absolute error we are taking ratio between mean absolute error to mean value, measured value. Relative error is equals to delta A by A mean. Percentage error means mean value into relative error into 100 we will do. Here in this problem different values we measured. After getting values, we are finding absolute error, mean absolute error and relative error and percentage error. Mean value means total readings by number of readings. That is the mean value 1.51. After getting mean value, delta A1. Delta A1 means mean value minus measured value A1. Like that delta 6 we are getting. Whenever we are taking mean value of this absolute error, that is mean absolute error, delta A1 plus delta A2 up to delta A6 by 6, this is the mean absolute error. After getting mean absolute error, relative error means mean absolute error by A mean, 1.51 mean value. Whenever we are multiplying with 100 to relative error, we are getting percentage error. Combination of errors. Suppose we are adding two measurements. Here this value A physical quantity is there. True value plus error, like that they will give. Next B physical quantity, true value plus error they will give. Whenever we are adding these two, x plus delta x means A plus A, B. True values separately we will add it. After that errors, delta A plus delta B we will add it. After that we will combine these two, true value plus error. Suppose we want relative error. Relative error means error by true value. Separately we add delta A by A plus B, delta B by A plus B we will do. Percentage error means into 100 we will do. Suppose we will take difference between two values. At that time true values, difference of true values, after that difference of error. true values we will subtract, errors we will add. Relative error means delta x by x is equals to delta a by a minus b plus delta b by a minus b. Percentage error means into 100 we will do. Whenever we are multiplying two physical quantities, at that time how to we will take error by true value plus error by true value, that means delta a by a plus delta b by b. Relative error means into 100 we will do. Whenever we want division a by b, at that time also whenever we are multiplying in product, same as it is plus only we will take. Here delta x by x into 100 relative error is equals to delta a by a into 100 plus delta b by b into 100. Same as it is whenever we are taking multiply, same as it is in division also we will take. Whenever power is there, x is equals to a to the power of n, at that time power into delta a by a plus, suppose b power m is there, power into delta b by b plus n into delta c by c. Whatever it is power minus, you must take positive only. In relative density, relative error multiply with 100. Next problem. In an experiment to determine the value of acceleration due to gravity using simple pendulum, the measured value of length of the pendulum is 31.4 centimeter, known to 1 millimeter accuracy, and the time period is 100 oscillations per pendulum is 112.2 seconds, known to 0.01 seconds accuracy. Find the accuracy in determining value of G. Here length of the pendulum is 31.4 centimeters, should convert into meters. Error in the measurement of length is 1 millimeter. Here I should keep it in CGS units only. 1 millimeter is equals to 0.1 centimeter, means 1 millimeter is equals to 1 by 10 centimeters. Given time 100 oscillations, 112.01 seconds means time period is time taken to complete one oscillation. 112 by 100 gives 1.12 seconds. Error in the measurement of time is delta t is 0.01 seconds. We know that time period is equals to 2 pi into under root of L by G, but we want G, both sides you should square it. G is equals to, cross multiply G and T, G is equals to 4 pi square L by T square. Now relative error, how to will write here? Error powers in decisions we will write. G value is delta G by G is equals to L power is 1 delta L by L plus T square means T power is 2 but it is minus 2. Whenever T square it will go up, power is minus 2, but we will take plus 2 only, plus 2 into delta T by T. Now substitute the values. Delta L is 0.1, L is 31.4 plus 2 into delta T. Delta T is 0.01, T value is 1.12. This value we are getting 0.023. Whenever we want percentage error is into 100, into 100 means 2.3 percentage we will get. Next problem. The time period of a seconds pendulum is measured repeatedly. Their times by two stop clock watches A and B. If the readings are as follows. First, A stopwatch readings, B stopwatch reading. What is the result? Here A is more accurate, means it is near to the true value. B is more precise, means in between value 2.56, 2.55, 2.57. Difference between any two value is very less difference. That's why it is precious. Whenever it is near to the true value, that is accurate. Next question. If L1 is 3.01 plus or minus 0.02 meters, L2 is 2.01 plus or minus 0.02. Now L1 plus 2 L2. L1 plus 2 L2 means, first of all we should add it true values. L1 is 3.03, L2 is 2.01 into 2 we will do. 2 L2 na, that value is 7.05. After that delta L1 and delta L2. Delta L2 is 2 into delta L2. Delta L1 is 0.02, delta L2 is 0.02 into 2 means 0.04. This total value is 0.06. Now L1 plus 2 L2 means 7.05 plus or minus 0.06 meters. Next, a body travels uniformly a distance of 13.8 plus or minus 0.2 meters in a time 4 plus or minus 0.3. Here 4.0 they will give. Suppose you won't observe properly, 40 will take. That's why be careful. 4.0 you will write as a 4. Then the velocity of the body. Now true values you should use. First of all, velocity is equals to distance by time. True value of distance is 13.8, time is 4. 13.8 by 4 is 3.45. This is the true value of velocity. Next, we want total velocity of the body. That means V plus delta V. Delta V is delta S by S plus delta T by T. That means errors delta V by V is equals to delta S by S plus delta V by delta T by T. Now whenever we will cross multiply, delta V is equals to V into delta S by S plus delta T by T. After substituting total values, 3.45 V value, delta S is 0.2 by 13.6 plus delta T is 0.3 by 4. After solving this value is 0.30705, means here V plus delta V is 3.45 plus or minus 0.3. Whenever we are substituting in formulas, at that time we won't add directly. Delta V by V is equals to delta S by S plus delta T by T, means V only, error only we want. At that time V into addition of errors we will take. The pressure on a square plate is measured by measuring the force on plate and the length of the sides of the plate. If maximum error in measurement of force and length are respectively 4% and 2%, then the maximum error in measurement of pressure is equals to F by A square. Area of the square is side into side is L square. That means pressure is equals to F by A is equals to F by L square. Means how to will write percentage error? Delta P by P into 100 is equals to F power is 1 into delta F by F into 100 plus L power is 2 minus 2 actually plus 2 we will take plus 2 into delta L by L into 100. They are given in question delta F by F into 100 4%, delta L by L into 100 2%. After substituting this value 4 plus 2 into 2 4 total 8%. Percentage error in pressure is equals to 8%. Next, the length of the rod is measured as 35.3 centimeters. Then the graduations on the scale are up to. Here graduations means least count. How much small measurement we will do? 0.3 centimeters means here in this up to last 0.1 centimeters we will measure. This is only least count. 0.1 centimeter, that means only one decimal is there here. 35.3 centimeters means up to 1 centimeters, 0.1 centimeter up to we will count it. This whenever we will count it in convert in millimeter, 0.1 centimeter into 10 millimeters is equals to 1 millimeter. If L is equals to 2.06 plus or minus 0.02 centimeters, B is equals to 1.11 plus or minus 0.03 centimeters, L plus B. L plus B means true value plus true value, error plus error we will do. L is 2.06 plus 1.11. This value gives 3.17. Delta L plus delta B. Delta L plus delta B means 0.02 plus 0.03 gives 0.05. Whenever we are adding directly, this is whenever we are substituting in that formula, we will use a different method. The radius of this sphere is measured as 5.2 plus or minus 0.2 centimeters. Then the percentage error in volume of the ball. Percentage error in volume. First of all, volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi r cube. Here radius value, true value plus error, 5.2 plus 0.2 centimeters they are given. Now volume percentage error, relative error, delta V by V into 100 is equals to power is 3 into delta R by R into 100. This value they are given. Delta R is 0.2, true value R is 5.2 into 100. After solving this, 11% we are getting. Next, if the length of the breadth and width of a plate are 5.0 plus, this is, be careful, 5.0 not 50, 5.0. Whenever they will give in points, observe carefully. 5.0 plus or minus 0.2 centimeters and 4.0 plus or minus 0.1 centimeters. Then the absolute error in measurement of area is, absolute error in measurement of area of the rectangle plate is length into breadth. Here L value is 5.02, 5 plus 0.2 centimeters, B is 4 plus 0.1 centimeter. 5.0 they are even, don't take 50, 5 and 4 only. Our confusion purpose they will give that points. Next, delta A by A is equals to delta A by A. Here absolute error, they are not asking total area, only error only they are asking. Error means delta A by A is equals to delta L by L plus delta B by B. Power is 1 only, that's why we are adding directly. Delta A we want, delta A is equals to A delta L by L plus delta B by B. Area means length into breadth. Length into breadth is 5 into 4. True value, area means true value, should multiply 20 into delta L is 2 means 0.2 by 0. Plus 0.1 by 4. Here delta L is 0.2 by 5 plus 0.1 by 4. That value is 0.04 plus 0.025 into 20. This is equals to 1.3 centimeter square. If the length of the cylinder is measured to be 8.28 centimeters with an error is 0.01 centimeter, then the percentage error in measured length of nearly. L is equals to 8.25, delta L is 0.01. Now percentage error in length, delta L by L into 100. Delta L is 0.01 by 8.28 into 100. This value is 12%. 0.12%.